Okay, so I'm happy with the camera. So I want to now actually acquire some images. So let's go into the TM imaging technique. So I left click on TM imaging, and then I just want to start with some baseline acquisition kind of parameter set. So I want to be in HDR mode, unbinned, which is this 2K. And the important thing is to just start with a short exposure time. So we want to go really with the fastest exposure time that we have, which for this detector is 10.6 milliseconds. Kind of equivalent conditions for anyone using a quantum camera would be, say, 4x binning and 10 milliseconds. So I'll start the view, the camera view, verify that that view starts. I have a noise image, so I'm happy that the detector is running and acquiring data, showing us the data. And then I'm going to go back over to the microscope UI. So first of all, I want to open the gun valve. So if I left click on the valve button, you see how the UI changes, and it shows us the beam path essentially. So initially the beam was blocked by the gun valve, so we didn't see any illumination. And now we see this parallel illumination passing further down the column, and then it's blocked by this green circle, which is the flue screen on the microscope. There's also some additional useful information at the top of this user interface. It tells you the imaging mode of the microscope, so GIF imaging. It tells us the magnification and the accelerating voltage. Generally, when we're doing anything parallel illumination with the GIF, we want to be in the GIF imaging optics mode. This is just a magnification series on the microscope that's lower magnification, and it compensates for the camera position. So the GIF camera is quite far along the column from basically the flue screen. So we have to have this special magnification series that we use. So in our software, it's called GIF imaging. On the Joel side, it will be called GIF mode. And on a Thermo Fisher scientific microscope, the equivalent would be called FTEM. Okay, so next I want to raise the flue screen. And then we see that the beam path is then clear all the way to the GIF camera. And hey presto, I have some illumination on the detector. So right now we have a multi-layer sample inserted in the microscope. It's a silicon substrate and I think a thin ruthenium oxide layer on the substrate.